Hello year 9s, welcome back to Mr. Chan's videos. How are you guys? So today in maths, we will be looking at interquartile range, which is pretty much one of the final bits for your year 9 statistics. So let's jump right into it. So the lesson objective are students will be able to understand how to find interquartile range through a set of ordered data, and also you will know what interquartile actually means by the end of this. Maybe some of you have heard of it before, but a lot of you might have never heard of this. You probably have heard of mean, median, mode, range. Yeah, but interquartile is something new and foreign to you. So let's begin. So we know, right? Median is literally in a set of data. Let's say you collect 50 different sample size, and the middle, which is if out of 50, 25, literally 25.5 is your median. Okay, if you 50 plus 1 divided by 2, which is how you find your median. Your middle out of your 50 sample size is 25.5. And what happens is you can separate that. Once you got your median, you can separate your data into two halves. Okay, you can separate your data into two halves, and these two halves can actually be divided into quarters. Okay, and that is in statistics term is called quartiles. There are 4 quartiles in the sets of data. It's kind of like the same as the best way to explain it is a basketball match. Okay, for basketball or your footy, you have four quarter game. Okay, so what happened is you have first quarter, second quarter, and then after second quarter is halftime break, and then after that you have third quarter and fourth quarter. So that's the same with your data. With data you have 4 different quartiles. Okay, first, second, third, and fourth, and second is obviously your middle. So the middle value of the lower half is called lower quartile. Quartile 1, I mean Q1, sorry. So, for example, if you, let's say, best way to describe it. So let's say if you have a set of data, okay. So let's say you have lots of data in here, and then your data present like a bell curve, okay. Lots of data in there. So what happened is you can actually split them into 4 halves. This is your quartile 1, that's your median, okay, and that's your quartile 3, Q3, third quartile, and then you have your finish over here, and then you have your beginning over here. So Q1, which is your first quartile, in here you have the 25% of all the data, okay. And then what happened is have a value equal or less to the lower quartile. 75% the quartile have of data have value greater than or equal to the lower data. So what happened is this is the 25%, and over here I'm going to use a different color. What happened here means is the remaining 75% of data is actually, they are actually better than quartile 1. So for example, you have, if you are taking a survey of all the heights of year 9 students, okay, once you have actually order your data out from small to big, I mean the shortest to the tallest person, okay, you will see this trend, as in the middle means most people on average, let's say 1.75 meters, that's the average height. Okay, so Q1, I'm just gonna make it up, it's probably 60 centimeters, which is 1.6 meters, and tallest here is probably 1.90 meters, okay, which is 1 meter 90. So what that means is, if you are below 160 centimeters or 1.6 meter tall, you are belonging to the bottom 25% of everyone, okay, that has been surveyed. But if you are above that 160 centimeters, you are actually in the top 75% of everyone that has been surveyed. Does this make a little bit of sense? Okay, so the middle value of the upper half is called upper quartile, or Q3. Okay, so what happened is, so this is the middle. Anything that above that is the top 50%. Okay, going past that, and anything above that Q3, which is the third quartile, is the top 25%. Okay, so I'm gonna use a different color. So this one, top 25%. So if you are, that means in this case it's 1.9 meters. So if you are taller than 1.9 meters and or above, you are belong in the top 25% of everyone that has been surveyed. So yeah, that's pretty tall actually. So that means what that, on the other hand, what that means is actually 75% of the data has value less than or equal to the upper quarter. So if you are at the top 25%, what that means is or everyone here is 75%. Yeah, because you are at the top 25%, that means you are the rest of the 75% of the people are actually shorter than you. Does that make sense? If it doesn't make sense, please let me know, and I will actually explain it a bit better in person to you by providing more example. So what that means is, in a whole set of data is, let's say if you survey 50 people, right, 50 year 9s, assume that everyone, there are 50 year 9s only at school, at our school. You can actually separate the whole data into Q1, median, Q2, which is the median is your Q2, okay, Q3, okay, so you can have Q1, Q2, Q3, which is a way to help you see how the data actually turn out. So what that means is, your interquartile range is actually a range of the middle half of the data. Okay, so interquartile range, actually, I'm gonna draw on another one again. So let's say you survey everyone and your data turn out to be like that. And as you know, this is your median, okay? And that is your Q1, okay, roughly the top 20, the bottom 25%, and that's your Q3. Anything above Q3 is top 25%. So what this leaves you is here, the interquartile range. The interquartile range, because this is the 25, I'm going to use a different color so that it doesn't confuse you. That's 25%, top 25%. That is bottom 25%. What that leaves you is in here. Okay, this is the middle 50%. Okay, that's your middle 50%, and that's what we do within. That's why we want to use interquartile range. That's the whole purpose of it, is to see the what is the range of the middle half of the data. Okay, so most of the time it means if everyone is about the same height, the range would be really short. Okay, because everyone is the same, so it's gonna repeat. This is the frequency anyway. Okay, this represents frequency. So, and if there are so many people with different height in the middle 50%, that means that thing is gonna be a bit wider. So I'm gonna show you one example to give you a better understanding. Just remember, interquartile range, to find that, all you need to do is Q3, the third quartile. Just take the whatever number that is, you minus the first quartile. Okay, Q1. Let's look at this for example. So for a data set, you have 7, 3, 4, 2, 5, 6, 7, 5, 5, 9, 3, 8, 3, 5, 6. So that's 15 numbers. Okay, so and out of these 15 numbers, you are required to find median, lower and upper quartile, and interquartile range. These are the three things that you have to find out. All three of these will be used in your assignments, so you need to know how to find this. So first step that you always need to do is you have to rearrange it from small to large, okay, ascending order. So small to large, once we arrange it, you have that, okay. That is your arranged version. So once you arrange it, there are 15 data value. You need to know to find the median. So median is literally the middle. And there's a formula that you can always remember, which is m plus 1 divided by 2. As you know, because there are 15 of them, so if you count, it will be the number 8. Okay, the number 8 is your data, is your median. But to get that 100% correct, you use m plus 1 divided by 2, which will be 15 plus 1 divided by 2, which is 16. 16 divided by 2 is 8. Okay, so the number is not actually 8, it's the 8th. Okay, the 8th, the sample number 8 is your answer. So once you got that, you actually need to, the 8th score, you actually need to go here and do 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's the 8th number, which is 5. So what happened is, now that you have found your median, you can actually find your lower and upper quartile. The lower quartile here refer to Q1 and upper quartile here refer to Q3. So once you got that, what happened here is you look at this. That 5 here has been taken out, okay, which is your median. To find lower quartile, you have to locate median first. The moment you locate median, you kind of just take out that median number. Okay, kind of look at this bracket there. It does not, both of those, they did not include 5, the median 5. So what happened is you got the 5 being not counted. So what is next is you need to find the median of that 2.5. Okay, because you separate the data from the middle, split them into two, and from there you actually need to find the median of the two split half. Okay, so look at that for a second. You will see on here you have 1, 2, 3, 4, 5, 6, 7. So 7 pretty much on each side. 7 sample on each side. And what you need to do is you still need to find the median of that. So to find the median of that, okay, so which is technically your median of lower second half or lower half of data is actually your Q1. Okay, so Q1, you want to find the median of Q1, which is n plus 1 divided by 2. Median always n plus 1 divided by 2, which is because there are 7 of them, 7 plus 1 divided by 2, which is 8. 8 divided by 2 is 4. So from there you can actually count is the fourth. So 1, 2, 3, and 4th. That is your Q1. Okay, so you know your Q1 is 3 now, and for Q3 you do the same thing because there are 7 sample. You use the same one. Look at this. Look at this. 7 plus 1 divided by 2, which is 8. 8 divided by 2 is 4. Fourth. Okay. 7 plus 1 is 8. 8 divided by 2 is 4. So fourth, again, is the fourth data starting from after the median. Okay, if you see here, you start counting after the median. The median is right there. You don't count that one. You start from here. 1, 2, 3, and 4, which is 7. Okay, so from there you have successfully answered the B. Once you got the B, you go to C, which is your interquartile range. So interquartile range is pretty much Q3 minus Q1, which is 7 take 3 is 4. So that's how you do, how to arrange them and find out your interquartile range. I'm going to show you an example here, one more. The following amount of money will withdraw from an ATM on a particular day. So that much money has been withdrawn. So you need to find upper median. Oh, what happened here? Ignore, cancel. I need to find median, need to find lower quartile again, which is your Q1, upper quartile Q3, and interquartile range, which is Q3 minus Q1. So let's begin. First thing first, you have to step 1, reorder. Okay, ascending, small to large. So this is gonna take me a bit of time. You can actually try this yourself by pausing the video and actually watch it back again to see if you got it right. So rearrange from small to large. I can see $60 is the smallest. So first you always look at what's the smallest. Then the largest will be $200. Okay. So the second one is $70. Okay, there's only one $60 followed by $70. And then oh no, it's actually 50. Alright, 50 there. I've totally missed that one. So 50, 60, 70. So 50, 60. Make sure we only have 160, yes, and only 170. And then after 70, you have 80. Do we have 80? Yes, we do have 80. And then after 80, do we have another 80? No, we don't. So we have 90. And then after 90, we have only 190. We have 100. There are two 100, and then after that, oh no, actually we have three $100, then followed by 120, and then followed by another 120, and then followed by another 120, then followed by 130, and then followed by 140, and then followed by 150, followed by, oh, we might not have enough space, oh no. Never mind, we can actually draw them out. So we have 180, and then we'll put it here. 180 will have 200, and yeah, right here. So what happened here is once you rearrange it like this, you want to count how many sample size you have. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we know our n is 18. So n there refers to sample size. We have 18 n, 18 sample. So once we got that, first thing we want to do is A, which is your median. So your median is n plus 1 divided by 2, which is 18 plus 1 divided by 2, which is 19 divided by 2, which is 19 divided by 2 is, if you use your calculator, it's 9.5 data. Alright, so 9.5 value. So what happened here is you have to count. Okay, so you have to count here 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. And 9.5 is actually in between these two numbers, which is in between 120 and 120. What you have to do then is you have to add those two together and then divide it by 2, which will give you 240 divided by 2, which will give you 120 again. So your median is actually $120. So once you got that, you know your median is right there. Alright. So now you can move on to find a lower quartile, which is your Q1. Okay. To find that, you need to split this into two halves. Okay. So the two half here is this half and that half. Remember in this case, because the median is in between two numbers, you can actually take those two the number, okay, besides it, okay, because it wasn't a specific number on your sample size, it is in between. So once you got that, you know you have two halves now, and each of the half has 9 sample size. Okay, so again you have to n plus 1 divided by 2, because lower quartile is essentially the median of the lower half, and upper quartile, which is Q3, is essentially the median of that upper half. So what that means is 9 plus 1 divided by 2, which is 10 divided by 2, which is fifth value. So your fifth value here, what happened here, you just count. So 1, 2, 3, 4, 5. So fifth value is your $90. Okay, and see, upper quartile. Oh, what happened? There you go, upper quartile Q3. Okay, same rules, same thing. M plus 1 divided by 2, which is again is 9 because the other half is equal to the bottom half. 10 divided by 2 is 2. Again, it's fifth value. So fifth value, so you need to count here. It's no longer is a 10, it's starting as 1 now, okay? Because it is the second half of itself. 3, 4, 5th. So fifth, there is your $150. So now, last part will be your D, which is your interquartile range. So interquartile range. Which is Q3 minus Q1. So your data here, Q3 is $150. Take Q1 $90, which will give you $60. Okay, so your interquartile range is $60. That's how you find it. Okay, so there is the middle half. What that means is the middle half from Q1 to Q3, there is a gap of, as in like that the data actually spread $60 apart from each other. Okay, in between there. So that's it for this video. I think it's long enough for you guys to concentrate on. Good job, guys. Please make sure you write down the notes and let me know if there's any problem. I will be more than happy to help you. Peace out. Bye.